In this question, we're told that the discrete random variable x has the following probability distribution, so as given to us in the table, where p and q are constants. The first thing we're asked to do is to write down an equation in terms of p and q. We don't have much, we haven't been given any additional information, so there's only one fact that we can rely on. We know these probabilities are exhaustive, and that adding together all of the probabilities should equal 1. So that gives us an expression that we can make, an equation that we can set. So simplifying, we get 2p plus q equals 0.5. In part B, we're now given some additional information. The expectation of x is 0.4. We're asked to use that to find the value of q. Okay, well, the expectation of x, that's going to take a product sum. We're going to multiply each of the x values by their corresponding probability and add all of those products together. So in this question, we'll have -2 multiplied by p, -1 times q, a half times 0.2, 3/2 times 0.3, and 2 multiplied by p. And we're going to set that equal to 0.4. From there, we'll just tidy up a little bit. I can see -2p, positive 2p. They all cancel each other out. That leaves us with -q plus 0.1 plus 0.45 equal to 0.4. A little bit more rearranging, and we finally end up with q equals 0.15. Okay, nice. That should actually be enough information to find p, which we're asked to do in the next part of the question. So, just recalling the original equation we've put together, substituting our q equals 0.15, a little bit of quick rearranging, and we get that p equals 0.175. Okay, moving on. We're given some additional information that the expectation of x squared is 2.275, and we're asked to find the variance. Luckily, we know that the variance is a combination of this expectation of x squared and the expectation of x that we were given earlier. So we'll substitute these into the formula. The variance of x is going to be 2.275 subtract 0.4 squared. Okay, into the calculator, and we get a variance of 2.115. Moving on in the question, we're told that Sarah and Rebecca are to play a game. A computer selects a single value of x using the probability distribution above. So x is the number that the computer selects. Sarah's score is going to be given by the random variable s, which is going to match the number that the computer selects. And Rebecca's score is going to be given by the random variable r, which is actually going to be 1 divided by the number that the computer selects. 1 over x, or the reciprocal of Sarah's score. Okay, there's some information to process there, and I realize I'm being asked to find the expectation of r. I want to summarize this in a table. This will give me a chance to compare the s and the r values, and I'm going to need a table anyway so that I can calculate the expectation of r. So this is how I'll set up the table. S values, R values, and the probabilities. S values are matching the X values, so I'm just going to get those down. R values are going to be the reciprocal of each of these, so 1 over -2, 1 over -1, 1 over 2, 2 over 3, 1 over 2. And the probabilities should follow through as they were originally in the table. So P was 0.175, Q is 0.15. And here's the table that we have together. Now let's find the expectation of R. The expectation is going to be a product sum. I'm going to be multiplying each of the R values by their corresponding probability. So that's the newly generated R value with the original corresponding probabilities. So the probability that x equals x. Technically, these should be lowercase s and r. So this should get us -1/2 multiplied by 0.175, -1 times 0.15, 2 times 0.2, 2/3 of 0.3, and 1/2 of 0.175. Okay, happy to just put this into the calculator and get an answer. The expectation of R, 0.45. Okay, moving on to part F. We're given a bit of a scenario here. Sarah and Rebecca work out their scores, and the person with the highest score is the winner. If the scores are the same, the game is a draw. We're first asked to find the probability that Sarah is going to be the winner. Well, we need to look at each of these outcomes and decide for which ones is Sarah going to be the winner. So, when the number selected by the computer is -2, Sarah is not the winner. She needed to have the highest score to win. When the number selected by the computer is -1, Sarah does not have the highest score. They both have the same score. When the number selected is a half, Sarah does not have the highest score. Rebecca's got a 2. When the number selected by the computer is 3/2, actually, now Sarah does have the highest score. And when the number selected by the computer is 2, once again, Sarah has the highest score. These are the outcomes where Sarah wins. So that's the probability where S equals 3/2 plus the probability where S equals 2. Just a reminder, on the original table, this would be where X equals 3/2 and where X equals 2. Those probabilities, 0.3 and 0.175. All right, add those together, 0.475. Okay, how about Rebecca? Which of these outcomes have Rebecca winning? Well, when the number selected by the computer is -2, Rebecca gets -1/2, and that is the highest score. When the number selected by the computer is -1, Rebecca also gets a score of -1. So nobody wins there. That's a draw. When the number selected by the computer is a half, we calculate Rebecca's score to be the reciprocal, which is 2, and Rebecca once again has the highest score. So there's 2 outcomes where Rebecca wins. So she wins where her score is -1/2, and she wins when her score is 2. Once again, a reminder, on the original table, this would be when the number selected by the computer is -2, and when the number selected by the computer is 1/2. Either way, the probabilities to combine are 0.175 and 0.2, giving us 0.375. Okay, that's the probability of each of them winning, and Sarah is more likely to win than Rebecca. Another question might be, how comes these numbers don't add up to 1? Well, Sarah winning and Rebecca winning are not the only outcomes. We also have an outcome where they draw. So they both get the same score. And that was when the number selected by the computer is -1.